Just to change any of the settings, you would hit the S. S and hold it. Now it's allowing me to say, here, optimal glide path 2. I like that, so I'm gonna hit the S and save that. 300 RPMs, I like it. But if I wanted to go to 500, I'd have to hit the arrow and knock it up, or go around. I can go to 100, but the 300 RPMs is really what you want to do, and you want to save it, hit the S. Apical action, I don't want it to slow down, I don't want it to stop, I want it to maintain its movement. So I'm gonna say it's off. Right now, the actual apex is set at a 0.5 millimeter short of the apex, which is called the apical foramen. People like that, but if you wanted to change it, and if you haven't touched anything for 5 seconds, it goes off. If you wanted to change it, hit an arrow. If you want to be 1 millimeter, or if you want to be at the absolute apex, then go down to 0. But most people like it at a 0.5 millimeter short of the apex, which is where everyone has used our Rootsy X2. Saving it. Auto start is on, meaning if the file is in the canal with your EDTA or sodium hypochlorite and the lip clip is on the on a saline soaked gauze pad on the opposite side of the mouth, you've created a circuit, and that will then auto start on, and you can also go to auto start off. Auto stop on, meaning you pull out of the canal, it's not touching any of the fluid, it'll stop on its own. The apical slowdown, I don't know anybody who wants to change the real speed of a file when you're actually conducting your root canal. That's the loudest it's going to be. It's not going to be overcome the sounds in your operatory. So that's as loud as it can be. If you wanted to go down, start at 0, 1, 2, but most people keep it at 3. And then withdraw sound. If you wanted a special sound for when it's withdrawing, I don't know why anyone would want that, and that's what you do. The other settings here, there is an optimal torque reverse, which is you guys have really, I don't know. If I save everything and I go to M3, it's just got it's very similar to what M2 is right now, but M3 is basically the same as your M2. When you go to M4, clockwise OTR. OTR is optimum torque reverse, meaning for a rotary file, every turn is broken down to degrees. Every 180 degrees or a half turn, it evaluates whether or not the load placed on the file, meaning whether or not the file is being somehow restricted, can increase, and if it is, we want to ease that restriction so that you don't break a file or ledge on a curved canal. So basically, the optimum torque reverse will reverse 90 degrees, and then we'll continue starting rotating forward, and every 180 degrees, every half turn, it evaluates whether or not the file is undergoing a load, and if it does, it'll reverse 90 degrees. But it doesn't come all the way out, it stays in the canal just with a half turn to actually a quarter turn to alleviate that restriction. It is counterclockwise, OTR. Whether or not that's gonna cut counterclockwise, you're just lessening the chance for file fatigue. M6, clockwise continuous. Here we have a high Newton centimeter, well, not that high Newton centimeter, you can change that, but a high RPM at 1,000 degrees just to break down a calcium blockage to get to the canal, and you can break that away with, say, a piezo reamer or some other kind of latch type. And then M7, if you have a stuck file, if the canal is stuck inside, I'm trying to turn that so you can see, stuck inside the canal, this is going to run in a counterclockwise position to alleviate the stick. I suggested that the first time around. You're going to evaluate whether or not you can get to the canal or not. You would use the piezo reamer just to break down that calcification with a high torque and a high speed. M8, is clockwise OGP. It's just different from the OGP2, in that it moves up 90 and back 120. So it reverses what you have here for M2, which is up 150, back 60. So it just changes up the actual the percentage rotation of the file. That's about it.